essentially almost all atoms are ions, which just means that they're charged. And the exceptions to those are the noble gases, also known as the inert gases. Again, this is the point of inertia. Every other atom, its defining characteristic is where it is, because everything's energy in motion. Some of it moves really slowly. Where is it along this ecliptic defines the nature of each element. And that's why there's like, things like depleted uranium. It's gone through a transformation of time. Again, everything's going through a crucible. Everything here is exposed to elemental pressure and time. But yeah, the nature of an atom is really just where there's a pulse and there's a life. An atom, A-D-A-M, A-T-O-M, created. And it's in a stage, a phase, currently. And that's the way we see it. But everything is in motion, and everything is on its way to becoming its opposite. Because there's a field mediation going on with everything when you get into looking at the whole Taurus field concept. Taurus fields are much like gyroscopes. This is a plane. This is a fixed plane, and it holds its rigidity in space. It tends to. And now, thinking about magnetism, again, this is a magnetic pulse. And when this pulse creates this perturbation in the field, this creates divergent centrifugal waves, and then once it gets over, coming back, it's convergent centripetal waves. Centrifugal, centripetal. And so, with this as a magnet, not all magnetic substances are just, magnetic substances aren't automatically magnets. They have to be magnetized. They have the potential to be a magnet, but you have to take, essentially, this is a T. Again, it's like a gyroscope. It holds that rigidity in space. And so, a magnetic substance may have all these little T's in it lined up awkwardly, and now, let's say this is the magnet, and all these torus fields within that magnet are lined up awkwardly. Now you take a bigger magnet, and you suck all of these T's, get them lined up with each other, commensurable. Then you've essentially activated the magnet. Now the magnet acts as a bit of a field laser. And it's the same thing with light. It's the same, all these little T's pointing in different directions. This would be incoherent light, like from the sun or reading light. None of these T's are lined up. They're pointing and rotating all in different directions. You get all those, again, line them up. Field commensurability, everything's, that's a laser. And it's really powerful because you can take, 100 watts of incoherent light, and, you can read a book about, 5 feet near it, or you can take 100 watts of a laser and you can, burn through a car door. It's really powerful to have field cohesion, as this is understood. And this is really field cohesion is the future of the understanding of science and technology, and the inventions of the future will really be based on understanding field cohesion and incommensurability. We'll get into those at a later time. But I want to think about light. One other thing I want to kind of talk about quick is light, because really important is to understand that this is a perturbation in a field. This is a field because there's a pulse. It's always happening on every possible scale. Light can be thought of as a coaxial circuit, and this is getting back into, I could have talked about this back in the Bible stuff, but coaxial circuit, just like plugs into your TV, brings the light onto your screen, brings those images. And it's got the thicker wire in the middle and the little wires on the outside. This thicker wire represents this. This is where this is the magnetic pulse wire, and that there's a pulse occasionally along that wire that continues to repropagate the wave pattern of electromagnetism traveling along that wire. And within, you know, like with a wire, there's insulation to keep all of that energy within, you know, the line, the power line, as it were, the cord. Obviously, out in the ether, those insulators aren't there, and so you know, the light spreads in all directions essentially. But what happens, it's about phase. And so when, you know, when this light comes back in right in time with the phase, it reproduces itself over and over and over again. As soon as that light starts falling out of phase, like when this light is incoherent and there's interference between the light shining, you know, from the sun, eventually that light falls out of phase enough that the wave stops repeating itself and the light essentially disappears. That's the limit that the light's able to travel, which is why lasers can travel so much further. There isn't all the interference. And so now let's think about light as, this is a little light up here shooting what science would call photon particles. These are solid things to science. And let's say this is glass. Now, first of all, you know, science has made a constant out of the speed of light, which is untrue, and which science knows to be untrue. Because in order to make, you know, yeah, light slows down in glass. Light travels at a different speed through moist air than it does through dry air and through water. You know, it depends on the medium that light's traveling as far as what the rate of speed. And what we'll understand eventually is that it's a rate of induction is the thing here. But they've actually changed in order to, you know, sell the idea. It's such a strange thing, but the speed of light being inconsistent raises a lot of questions and makes people think. And they don't want you to do that. They want you to read and repeat. So the absurd thing that they've done is they've taken the length of the meter and made it inconsistent, variable, depending upon the speed of light. So a meter in water is a different length than a meter in glass and a meter in desert air. They're different lengths. They've made it variable so that they could continue to call the speed of light a constant. But it's not. And so now what happens here, this light will be traveling through the air, and so this light will be traveling through the air, and it'll slow down when it hits this. This particle supposedly hits this glass, slows down, and when it gets to the other side, it picks back up, it speeds back up again. And you know, it's depending on this glass's dielectric permittivity. That's the defining factor of how much it slows down as it goes through. But when it gets, this is the thing, when it gets to the other side, the light accelerates immediately right back up to speed, assuming this air is the same. You know, and science has no explanation. There's no new force applied to re-accelerate that light back up to, immediately back up to speed. It's because it's a rate of induction. It's a totally different concept. And it's all about perturbation in a field. And this is a perturbation in a field. And all of this, these are all, you know, little atomic pulses of light repropagating themselves in the pulse of the ether, which is everywhere. But once that phase runs out of phase due to interference, The wave stops collapsing in time with the pulse, and the wave dies off, and you're out in the dark again. But to think of this as a perturbation in a field, think about yourself. Think about this as a field of water, and think about you here splashing, creating a perturbation in this field of water. And out on the edge, once the wave gets, this is the wave, you've created electricity and energy and motion. Once it gets to the shore, you wiggle sand around, and maybe a frog jumps off a stick, and there's some effects that happen, and there's ducks might bounce up and down on the water. But you didn't do anything. You didn't reach out and touch those things. You didn't add any particles that created the force to go out and do that. All that you did was create a perturbation in a field that created all of those effects. The ether, when it comes to light, the ether is everywhere. You're just creating a perturbation in the field of ether reveals itself. Just like, a fish in a really still pond probably does not notice the water. But I bet when, the motorboat cruises past and creates, all of that motion in the water, suddenly, whoa, the water reveals itself because the field was perturbated. It's really important to understand that perturbation in a field concept.